Today's video will demonstrate how to conduct a program trace. Hello, I'm James Helfrich. We often want to debug a program before it is actually written. In other words, when it's still as pseudocode or as a flowchart. But how do you do that? This video will demonstrate the technique called program trace, in which we track the program line by line and record the output and see if the output is what we expect. A program trace is a line-by-line analysis of a program to try to determine its output. For an example, take a look at this Swift function to compute if we have a leap year. Notice the line numbers on the right. Now we're going to start by listing the variable names on the column headers. And there's two variables, year and is leap. Execution starts at line number 19. And at line number 19, we have our test case, which is the year 2000, and is leap is not yet defined. Then at line 21, my year remains unchanged. Now notice year mod 4 does equal 0, so we do not go into line 22. Instead, we go into line 23. At line 23, year mod 100 does equal 0, and so we don't go into line 24, we go into line 25. Now at line 25, year mod 400 does equal 0, so we're going to proceed to the else condition, which is line number 28. And here we're going to set is leap for the first time, and it becomes false. And then we exit the function at line 30 with false. Now notice the trace table does not contain every line of code in the function, just the lines of code we execute. And we can also see the history of the program by tracing it back. So I can see, for an example, at line number 23, the value of year was 2000 and is leap was not yet defined. So a program trace is a technique where the table is built containing the values of variables at various stages of execution. This table represents the variables in columns, stages of the program in rows, and the values of the variables at specific times in execution in the interior boxes. This allows a programmer to be able to easily see the values of the variable at a given time. So we're going to start by identifying our test cases, and normally we need more than one test case to test a function. And then we're going to number the lines of code, and if we're using this in a code editor, we get that for free, but if not, we'll just put little numbers on the side. And then we're going to create the trace table by doing a line-by-line execution. And then finally, we're going to interpret the results. We're going to compare the result of the function with what we expected to happen to see if we have a bug. So let's take a look at this. I want to create a program trace for the following code with the input of 12,000 and 125,000. And this will determine what my tax burden is. And I should get 10% and 28%. So my first test case is going to be 12,120. So I create my trace table here. So I have two variables, my tax and my bracket. Now, initially at line number 368, then my tax is going to be 12,000 and my bracket is not yet defined. Now, since 12,000 is less than 61,000, I'm going to proceed to line 369. And there my tax remains unchanged. And it looks like that I am in fact less than 15,000 as well. So now I'm going to proceed to line 370. My tax remains unchanged. And now I assign my bracket to 0.1. Okay, I'm going to do another test case, 125,000. So I need a new table for that. So I have a different trace table for every test case. Initially, I'm going to start at line number 368. And my tax is going to be 125,000. And my bracket is not yet defined. Now, since 125,000 is not less than 61,000, I'm going to proceed to line 374. And here my tax remains unchanged. And then I'm going to go to 375. Now 125,000 is not less than 123,000. So I'm going to go to my else condition, and then I'll assign 28. Now when I compare my results, we'll have my two test cases. For my 10% tax bracket, I expected 10% and I got 0.1, which is in fact 10%. And for my 28% tax bracket, I expected 28% and I did in fact get 0.28. So therefore the function works. Let's take a look at another example. This one involved loops, not decisions. Now, I didn't have line numbers here, so I'm just going to put comments with my line numbers on the side. So I'm going to do a trace table here, and I'm going to start with I up is going to be on line number 1 is going to be 0, and I down is going to be 8, and output, there's going to be no output here. Now I'm going to go to line number 2, and I up and I down are unchanged, and I up is less than I down, so I'm going to proceed inside the loop, and I'm going to do the output, 0 to 8. Now, I up gets 1, I down minus 1. So now 1 and 7 are my updated values for I up and I down. So I'm going to go back up to the loop here, and number line 2, and 1 is less than 7, so I continue. Now notice how I color code my table here. This helps me easily see what parts are related to a given instance of the loop. I'm going to print the output here, 1 to 7, and now I'm going to increment I up and decrement I down, so 2 and 6. So now I'm going to go back up to line 2, 2 and 6. Line number 3, do my output. Line 4, and I up is 3, and I down is 5. Go back up to line 2, 3 and 5. Go to line 3, do my output. Go to line 4, and now 4 and 4 is my result. Now I'm going to go back up to line 2, and since I up is not less than I down, I'll exit a loop at that point in time. And therefore my output would be 0, 8, 1, 7, 2, 6, 3, 5. And notice how I can once again go back in time by looking at the value of the table at a given moment in time, and that shows me what the variables were and the state of the program. This was example 6.1 and 6.2 in the trace chapter of the software design textbook.